Today I am going to focus on velocity time graph. And first we have to understand what exactly is velocity time graph. A graphical representation in which velocity is taken in y-axis and time in x-axis to show the relation between velocity and time is called velocity time graph. And this is just the definition, but our focus is how to represent the motion of the body in velocity time graph. For this, I have taken one numerical problem. Draw a velocity time graph for a body which has a velocity 15 meter per second in first 3 seconds, then minus 20 meter per second in next 5 seconds, and 10 meter per second during last 2 seconds. Motion is different in different time period. And lastly, another question is also added. Calculate the total distance covered and displacement of the body. We have to represent the motion of this body which is moving this way graphically by velocity time graph, and we have to calculate the total distance covered by that body and displacement of the body with the help of that graph. Okay, look at this is x-axis and this is y-axis. Velocity in y-axis it is taken in meter per second, and time in x-axis it is taken in second. We have to divide y-axis and x-axis into equal parts. In this way, according to the numerical problem, we have to go up to minus 20 meter per second. That's why at least below 0 we must have minus 20, and I have written up to minus 25. In the same way, in the upper side also I have taken the same distance, and so the velocity is represented in y-axis 0 to minus 25 negative and 0 to 25 meter per second positive. In time axis I have taken 12 seconds because according to the numerical problem we have to go up to only 10 seconds. Okay, let's start. I mean to say we have to see that numerical again and we have to plot the graph according to the given information of the numerical problem. Draw a velocity time graph for a body which has a velocity 15 meter per second in first 3 seconds. 15 meter per second in first 3 seconds. How can we plot it? Here we have 15 meter per second and the motion goes up to 3 seconds or up to this point, and that's why we can draw a straight line which represents the motion of the body 15 meter per second till 3 seconds. Now next information, then minus 20 meter per second in next 5 seconds. Now velocity is changed. It is minus 20, means we have to go to this value. It will be better to represent this by a dotted line. Actually this dotted line doesn't represent the graph. Just to go up to 20 meter per second I have drawn this dotted line up to 20. Now the body moves from 3rd second to 8th second, 1 2 3 4 5 till 5 seconds with the velocity of minus 20 meter per second. It is represented by straight line. Now again we have to see the numerical. What is given third information is and 10 meter per second during last 2 seconds. Now in last 2 seconds its velocity is 10 meter per second. 10 meter per second is here and we are at the position of 8 seconds. That's why we have to go up to this point with dotted line. Now the straight line which starts from 8 seconds and goes up to 10 seconds, it means till 2 seconds the body moves with the velocity of 10 meter per second is represented by this straight line. If we plot a vertical line from this last point, then we'll have another rectangle. We have altogether 3 rectangles. This is the graphical representation of the motion given in the numerical problem. Okay, after this, there is another part also in the numerical problem. Look at this part, second part. Calculate the total distance covered and displacement of the body. We have to calculate the total distance covered by that body and the displacement of the body also. How to get this? This is A, which is a rectangle, and this is B, another rectangle, and this is C, another rectangle. The area of this rectangle, if we add them numerically with proper sign, then it gives displacement. A minus B plus C gives displacement because rectangle A represents positive displacement, rectangle C represents again positive displacement, but rectangle B represents negative displacement. That's why if numerically these area are added with proper sign, then we'll get displacement. But if they are just added with each other, a plus b plus c, it gives the distance. The addition of the area of each of the rectangle gives distance. Okay, now we are doing this. Displacement is equal to area of rectangle A minus area of rectangle B plus area of rectangle C. According to our graphical representation, look at this. Area of A is equal to 15 into 3, but area of B is equal to what? It is minus 20 into 5, but area of C is equal to this 10 into 2. And the same we are representing here. 15 into 3 area of rectangle A minus area of rectangle B is 20 into 5, and area of rectangle is 10 into 2. This first value is velocity and second value is time. When velocity is multiplied with time, we'll get displacement. 15 into 3, 45, 20 into 5, 100, and 10 into 2, 20. That's why the displacement is minus 35 meter. What it means? It means the body is at the position of 35 meter opposite to the reference direction. Okay, now for distance, area of rectangle A plus area of rectangle B plus area of rectangle C. Now area of rectangle A is 15 into 3 and B is 20 into 5 and C is 10 into 2, and we have 45 plus 100 plus 20, and this is equal to 165 meter. The total distance covered by the body is 165 meter. Thus we can calculate the displacement and distance with the help of velocity time graph also. Okay, today I want to stop it. We'll meet in another class with some other matter.